This is chapter 5, software design of Dr. Rajib Mal's book. So, the first question is, what do you mean by the term cohesion and coupling in the context of software design, and how are these concepts useful in arriving at a good design of a system? So, cohesion, as we know, that it is the workability or the task which is assigned to a module, how far it does or it completes its task, that is cohesion. And coupling is the interdependence between two or other modules. So cohesion has to be as high as possible, coupling we need to be as low as possible. The answer is cohesion is a measure of functional strength of a module, whereas this functional strength is among the functions of the module, because if module has been assigned some work, we assume and we want module to do that work completely, entirely. Whereas the coupling means between two modules is a measure of degree of interdependence or interaction between two modules. Now you can just explore it for various other modules, means it's not subjected to two modules, but the definition of coupling is refined or being set for two modules only. Now cohesion and coupling helps in arriving at modular design. If you are adopting a modular design, then cohesion and coupling they help you to arrive at this design. Second question is enumerate the different types of cohesion that a module might exhibit. So there are various types of cohesion. We have coincidental cohesion, logical cohesion, temporal cohesion, procedural cohesion, communicational cohesion, sequential cohesion, and functional cohesion. Then this is question 3. Enumerate the different types of coupling that might exist between two modules. Couplings are data coupling, stamp coupling, control coupling, common coupling, and then content coupling. Fourth is it true that whenever you increase the cohesion of different modules in your design, if you increase the cohesion of different modules in your design, coupling among these modules automatically decreases? You need to give or justify your answer. So before going to this, let me answer, because the answer is not given in the solution manual we provided by Dr. Rajib. Now, you have modules. Say we have two modules. Now this module is performing its work. The functional strength of this module is quite high. We are trying to increase the cohesion, and similar is with the case with this module. This module is also performing the work it is being set to do. And once this module and this module are entirely working on the work they are supposed to do, they will not have interdependence. So interdependence will be least as possible. So this is true. Fifth is what, according to you, is a good software design. You covered it in length, so we'll try to answer. The characteristic of good design are what we are going to explain to you today. This in this answer, but these characteristics are very important. Apart from this, there are various explicit or implicit features also. But for the time being, let us see. First is the correctness. That means if you have a good design, then it should correctly implement all the functionalities of the system. That means good design means the software should be correct. Understandability. If you are able to understand the design, it is good. If it is efficient, it is giving you the result what you have been trying for, and in less time or up to your thoughts or required limits. It is efficient. Maintainability, that means it is amenable to change, because ultimately we have seen that 60% of the effort it goes in maintenance. So if it is good for modification, if it is understandable and it can be modified, and it is, you can have adaptive and perfective maintenance on it, then we say it is maintainable. Sixth question is, what do you understand by the term functional independence? Functional independence in the context of software design. What is the advantage of functional independence, and how can you achieve functional independence in a software design? So, a module, this is a module, if it has high cohesion and low coupling, this is said to be functionally independent of other modules. And this functional independence, by this we mean that the cohesive module performs a single task or a function. Cohesive module, it performs only that task which it is supposed to do. And the functionally independent module, they have no or minimal interaction with other modules. So functional independence, this is a key to any good design. And let us see the reasons also. First is error isolation, scope of reuse, and understandability. What is error isolation in terms of functional independence? Functional independence reduces error propagation. Why? If a module is functionally independent, its degree of interaction with other modules is less. So, error which exists in one module would not directly affect the other modules. So, error are isolated. Even if error is somewhere, it will not be propagated to other modules. Then we have scope for reuse. Why? Since module does some well-defined and precise functions, and interface of the module with other modules is simple and minimal, then a cohesive module can be easily taken out from your program or from your software product, and it can be easily used or employed somewhere else without much change. Then we have understandability. What does it mean, understandability? It is, the complexity of the design if it is reduced. Hi. Since different modules can be understood in isolation, as modules are not dependent on each other. That is why they are more understandable. Question 7 is explain why a design approach based on the information hiding principle is likely to lead to a reusable and maintainable design. And you can give also a suitable example. So, design approach based on the information hiding principle. This is quite obvious that this information hiding is actually making your code reusable and maintainable, because information hiding facilitates low coupling and high cohesion among the modules, and thus making the modules functionally independent. So, state whether the following statements are true or false. Give reasons. First is the essence of any good function-oriented design technique is to map the functions performing similar activities into a module, and this is false. Why? Again, we'll read the question. The essence of any good function-oriented design technique is to map the functions performing similar activities into a module. And this is false because the design would have low cohesion. We want high cohesion. The functions that together achieve some meaningful result should be mapped together, right? B. Traditional design is carried out top-down, whereas object-oriented is normally carried out bottom-up. Is it true? This is true, because traditional design is based on decomposing the high-level functions into subfunctions and subfunctions and then subfunctions and so on and so forth. While in object-oriented design, we first try to identify the objects. These are natural objects which are in a problem. And then we try to identify the relationship, the behavior, the interdependence of these objects on subfunctions. And then we combine them to more abstract classes and so on and so forth. So object-oriented is bottom-up type of methodology, while traditional design is top-down. Ninth question is compare relative advantages of the object-oriented and function-oriented approach to software design. Object-oriented techniques, now it is worldwide, all these languages after C++, they are more or less object-oriented only. Because of its simplicity, code, design reuse, they are providing. And also, lower development time, lower cost time, robust code, and easier maintenance. These are the advantages of object-oriented over function-oriented approaches. Question 10 is name a few well-established function-oriented design techniques. And for this, we have already seen in the lectures discussion of the chapter. It is Constantine and Uden, Hartley and Pirabai, Gain and Sarson, DeMarco and Uden. 11th is explain some of the causes and remedies of high coupling between two software modules. What is the cause? What is the after effects? First of all, if you have a highly coupled modules, then you will have to provide complex interfaces among the functions. You have to use global data because both the modules are interdependent and they will use some global data. And then finally, you will have improper distribution of function to modules. Question 12 is what problems are likely to arise if two modules have high coupling? Again, when you have high coupling, it will be very difficult to understand the function of the modules, and you cannot reuse a module because one module is dependent on another for some or other work, and debugging is also very difficult. 13 is what problems are likely to occur if a module has low cohesion. If it has low cohesion, it will be difficult to understand, debug, and reuse the code again. 14th, distinguish between high level and detailed design. What document should be produced on completion of high level and detailed design? So, first we have we formulate or make high level design, then we go for a detailed design. During high level design, the components of the system and their interactions are identified actually. So, components and the interaction among the components. And while you are doing detailed design, you actually try to formulate the algorithms, the data structures, these are identified. Then, on completion of this high level design, the module structure in the form of structure charts, this can be produced. Once you complete high level design, the module structure in the form of structure charts you have already read can be produced. And what about the detailed design? We formulate or present the module specification document on the completion of this detailed design. 15 is what is meant by the term cohesion in context of software design. Is it true that the good design, the modules should have low cohesion? Why? As we have already seen, cohesion is the measure of functional strength of a module. So it would be difficult to understand, debug, and reuse the module if it has cohesion which is low. The answer to the second is it true that the good design, the module should have low cohesion? No, cohesion should be as high as possible. Question 16 is what is meant by the term coupling in the context of software design. Is it true that in a good design, the module should have low coupling? First, we'll answer the second one. It is false because it is true. It is true actually. The module should have as low coupling as possible. That means the interdependency between two modules should be as least as possible. Now let us answer it. Coupling between two modules is a measure of degree of interdependence or interaction which is happening between these two modules. As I suggested, yes, in a good design, the module should have low coupling. When two modules, they are supposed to have high coupling, it becomes difficult to understand the function of the modules and to reuse the modules also. So debugging would become difficult. Question 17 is how would you improve a software design that displays very low cohesion and high coupling? How are you going to do that? Just by distributing the function to modules, and you need to redesign the modules. The only option is redesigning. 18. What do you understand by the term top-down decomposition in the context of function-oriented design? What we do in traditional design, we decompose the high-level function, those are managerial functions actually, into sub-functions, again in sub-functions and so on, till the time it can be represented as algorithm. So this is referred to as top-down design. 19. What do you understand by layered software design and what are the advantages of this layered software design? So in a layered software design, the modules are arranged in layers. And these layers, it will improve your understandability of the design and it will make it more maintainable also. Question 20 is what is the difference or principal difference between software design methodologies which are based on functional abstraction and those based on data abstraction? Name at least two unpopular design techniques based on each of these two software design paradigms. So let us answer them. Object-oriented techniques are based on data abstraction. And structure analysis and design techniques, they are based on functional abstraction. So object-oriented, data abstraction, structure analysis and design technique based on functional abstraction. Question 21 is what are the main advantages of using object-oriented design approach over a function-oriented approach? There are various options and advantages. We have seen this answer already given, but we'll go through it again. First of all, object-oriented design or techniques, they are simple code and you can reuse it, and they are more robust, they offer low development time, low development cost, and they are maintainable, amenable to change. 22. Point out three important differences between functions-oriented and object-oriented approach of software design. So, first is, unlike function-oriented design, this OOD, the basic abstraction, are not real-world functions such as saw, display, track, etc. Right? But it will have real-world entities as objects like employee, picture, machine, radar system, etc. In object-oriented design, the state information is not represented in a centralized shared memory, but it is distributed among objects of the system. Object will have their own data and their own function. Then function-oriented techniques such as SASD, that is software analysis and software design, it group functions together as a group, and they constitute a high-level functions. Then, in the case of object-oriented techniques, group functions together on the basis of the data they operate on. So this was the chapter on software design. These are the solution hints. Thank you so much. Take care.